Have you ever dreamed of traveling to the distant future, or maybe hopping back in time to witness history firsthand? What about zipping across the galaxy in the blink of an eye? For centuries, these have been the dreams of science fiction. But what does actual science say? Can we really bend the fabric of time and space? Let's start with Albert Einstein. His theory of general relativity completely changed how we understand the universe. He told us that space and time are not separate, static things. Instead, they are woven together into a single, four-dimensional fabric called spacetime. And here's the mind-blowing part. Massive objects, like stars and planets, don't just sit in spacetime. They warp it. They curve it. Think of placing a bowling ball on a trampoline. The fabric sinks and curves around it. That's what massive objects do to space-time. This curvature is what we experience as gravity. It's not some mysterious force pulling things together. It's just objects following the curves in space-time. The Earth orbits the Sun because it's rolling along the giant curve the Sun creates in the fabric of space-time. And this isn't just a theory. We've proven it. During a solar eclipse, we can see light from distant stars bending as it passes by the Sun, exactly as Einstein predicted. GPS satellites in orbit have to constantly adjust their clocks because time actually runs slightly faster for them than for us down here on Earth, thanks to this warping effect. So, we know space-time can be bent. The big question is, can we control it? Can we bend it enough to create a shortcut through space, what we call a wormhole? Theoretically, a wormhole, or an Einstein-Rosen bridge, could connect to distant points in space or even to different points in time. Imagine folding a piece of paper in half and poking a pencil through it. That's the idea, tunnel through space-time. The problem is, according to our current understanding, these wormholes would be incredibly unstable. They would collapse in an instant. To keep one open, we'd need something with negative energy or exotic matter. This isn't antimatter. It's something entirely different. A hypothetical substance that has a sort of anti-gravity effect, pushing space-time outward instead of pulling it in. We've never observed exotic matter, and we have no idea how to create it. It's a huge theoretical hurdle. Then there's the idea of a warp drive, like the one from Star Trek. This concept, known as the Alcubierre drive, suggests we could create a bubble of space-time around a ship. This bubble would compress space-time in front of the ship and expand it behind, effectively moving the bubble and the ship inside it faster than light, without the ship itself actually breaking the cosmic speed limit. The crew inside would feel no acceleration at all. Sounds amazing, right? But just like wormholes, the Alcubierre drive would require enormous amounts of that same mysterious negative energy to work. Some calculations suggest you'd need the energy equivalent of the entire mass of Jupiter. So, while the math works out on paper, the engineering challenge is, for now, completely beyond our reach. And what about time travel to the past? This is where things get really tricky with paradoxes. If you went back in time and prevented your parents from meeting, how could you have been born to go back in time in the first place? This is the famous grandfather paradox. Some physicists believe that if time travel to the past were possible, the laws of physics would somehow prevent you from creating a paradox. Maybe you'd find you simply can't change the past, or maybe you'd create a new, alternate timeline. So, can we bend time and space? Absolutely. The universe is doing it all the time. But, can we control it to build wormholes and warp drives? Right now, the answer is a firm maybe. It's theoretically possible. But it would require breakthroughs in physics that are as revolutionary as Einstein's own theories. It might take centuries, or it might be impossible. But the fact that we can even ask these questions and explore them with mathematics shows just how far we've come. The dream is still alive, waiting for the next great mind to show us the way. What do you think? Will humanity ever master space-time travel? Let me know in the comments below. Thanks for watching, And don't forget to like and subscribe for more journeys into the cosmos.